my name is Deepak. I run the container services team at AWS. I also run the AWS Batch and HPC team, which you just heard about in Werner's keynote. I'm also joined today by several members of the container services org. Maybe some of them are still trailing in, but the ones who are there, if you could stand up. See two up here. There'll be more showing up. They're also walking over. We'll be here throughout the day. You'll get a chance to talk to them. We love getting your feedback, listening to feature requests, hearing about some of the challenges you might be facing. Our goal is to try and help you solve all of them. So it was in Werner's keynote about 2 years ago that we announced the preview for ECS. It was exciting times, and we became generally available in April of the next year. Since then, we've also launched a container registry, and in general, adoption of containers has really taken off. And we are seeing rapid adoption of containers on AWS for all kinds of applications. And I'll talk a little bit about what we are seeing and how that might, the trends and evolution of how people are using containers a little bit. It's not just people using ECS. There's a number of other container orchestration platforms that our customers have choose to use, and we have partners who provide and support those on AWS. Some of them in the audience today, and I'll actually, you have folks like the folks from CON316 who provide a great management layer on top of the core ECS and other AWS functionality that makes it easy to consume containers on AWS. So if you're running Mesos, something like Docker Swarm, or Docker for AWS that the Docker folks announced yesterday, Kubernetes. There's a number of choices, and we'd like to make sure that all of them run very well on our platform. And it's really exciting time to be involved in this space because I think it's still very, very much in the early days, and there's a lot of innovation to come. Our customers started off simple. About 3.5 years ago, was the first time when people started asking us about, hey, what can AWS do to help us with containers? Docker's, about three. Docker's a little over 3.5 years old. And what I want to do is, as people have started building applications and running them in production, that's what impacts our roadmap. It's reflected in our agenda today, and we'll cover many of the things that we'll cover features that we've launched, et cetera. But what I really wanted everyone in this room to walk out with was to understand some of the rationale and some of the challenges that we want to solve and how we think about them. And maybe you'll get a better sense of what we're trying to do and how you may be able to leverage the service. I actually have a clicker, I should use it. So, as I said, about 3 years ago was the first time we really started having a lot of customers coming to us and saying, hey, we run containers on AWS, we're trying to move them into production, we need your help. So we started trying to tease that problem apart. What did it mean for customers to go from a laptop to run a production application? What are the problems that they were facing when they were trying to do that? And they essentially boiled down for us into 3 core buckets. The first bucket was cluster management. People were running these resources on top of EC2 instances. They had to run some form of cluster management software. They had to manage the configs. Then they had to make decisions like, what happens when I'm running in 3 AZs? What happens when I'm scaling from one application to one really big application? Or even more interesting, from one small application to thousands of applications, some medium, some large, some small, across an organization. And how do we manage that? How do we manage? So all of that was one of the biggest pain points that our customers had. And it was pretty clear that was one that we needed to solve. The other problem they wanted to solve was container orchestration, which is, OK, now I have all these, I built this cluster. I kind of have a resource manager. Now I have to put my containers and place them across this cluster in an efficient way. I need to manage the lifecycle of my applications. Help me do that. And the last one, and that's especially true for customers who've been on the AWS platform for a while, is you have all these cool features. We launched another, 15 or 16 in the last 2 days. How can we leverage them? How can we integrate with them? And we like to do that better from a container infrastructure. So the first thing we did, and the first thing we wanted to do, was build a fully managed service, which means there should be no need to run your own resource manager, your own cluster manager. I come from the HPC world, and in the HPC world, every cluster, and that's true for most clustered solutions, you have this head node or a master node. And that's a proverbial single point of failure and pain in the neck. You have to figure out how to scale it. You have to figure out how to manage its lifecycle. You have to figure out what happens when it goes down. I fundamentally believe, and many of us, we do as a team, that that's something that doesn't translate well to an elastic cloud infrastructure. So we wanted to build a system where you did not have to run that and figure out how to scale it. So if for those of you who used ECS 2 years ago, and there are some of you in this audience, we didn't even, in our preview, we didn't even have any fancy schedulers. All we had was a really good, highly scalable and efficient resource, highly reliable resource manager. And that remains one of the most popular features and capabilities of the ECS platform. Every time we talk to customers about what they like most about the platform, about ECS, for many of them, the fact that they don't have to operate their cluster management infrastructure remains one of the key reasons they use us. AWS has many, many services that do a bunch of things. Many of them we consider core parts of the platform. Things like identity, monitoring, how we scale systems, how we load balance. There's services across the board. And initially, in the early days of containers, you had to kind of figure out how to make them talk to your container infrastructure. You had to do some of our customers have done some rather heroic things to make that happen. And we wanted to make that a lot easier. But it wasn't just about ECS integrating with the rest of the AWS platform. It was also about helping other teams at Amazon understand what it meant to support containerization. I'll talk about this a little bit more later, but a great example of this is our load balancing team. We collaborated very closely with them on the application load balancer, because that was the properties and capabilities that it now provides ECS customers were pretty clearly things that we needed to do, but other people running containers on AWS also wanted those capabilities. So those are core missions for the team, and we provide them to customers through ECS. So here are some common use cases. I will start with the last one. For anyone who started running Docker, who's using containers, doing some form of deployment and continuous deployment, is often the first use case that they find for running Docker. And no surprise, when we launched ECS, right off the bat, there was a whole bunch of folks who started doing that. And it really took off once we launched the container registry, because you need to store your images somewhere, and that gives you a great starting point. That resulted in a bunch of partnerships with companies like Worker, with CodeShip, with Shippable, with CloudBees, who wrote a Jenkins plugin for ECS to try and make your software deployments a lot easier, all in a containerized Docker world. Somewhat surprisingly at the time, but perhaps in hindsight, not that big a surprise. Right after we launched in preview, and especially once we went GA, our batch processing use case just exploded. And initially, when we had talked to customers, most of them were not doing batch, and we wondered why this got so popular so quickly. And in hindsight, the reasoning is simple. Batch processing does not require complex networking, does not require complex orchestration necessarily, at least for a lot of simple batch cases. It needs efficient resource management, it needs an execution environment, and it needs the ability to scale really quickly, all of which you got from ECS. And people started using it so much, so we ended up building a service on top of it called AWS Batch, which I'll talk about later, and you'll have more deep dives on. The most common use case for us remains people doing microservices. I use that in air quotes because I don't think anybody agrees on what that means. But the general idea is that people break up their applications, they start splitting them into small decomposed units, either because they want their developers to move faster or they want to set up teams that way. The goal is to get productivity and better operational control over how they're running their infrastructure, especially as they scale. And then you have customers and partners who've kind of built platforms on top of that for their developers to leverage. So whether it's folks like Convox, whether it's folks like Meteor with Meteor Galaxy, folks from Remind with the Empire platform, there's a number of application platform services available on ECS that developers can leverage. And they definitely make it, they give you a really nice tool chain to take advantage of the capabilities that the broader platform offers. There are also a lot of large enterprise companies that have built internal platforms for their own development teams. These may be things that just they have developed, or they may start with an open source project and sort of smith it for their own use case. But that remains, again, a very, very common use of ECS. And the types of customers we get range from startups like Airtime, it's a video chat software, to companies like MyTaxi. So I learned yesterday that MyTaxi is really big in Germany. They don't have Uber there, so everyone uses My Taxi. And every new year, they basically used to have these tremendous scaling problems. They got 350% more traffic on that one day than they got the rest of the year. And they were having trouble scaling their app. So they moved to ECS. They split their application up into about 50 services. So it's 50 microservices, if you want to call them. They leverage a lot of the ECS infrastructure. And last New Year was the first time they ran with that, and they did just fine. You have folks like Lyft that are heavy users of the EC2 container registry. And you'll hear from some of these today. You'll hear from companies like here that do mapping, and it's pretty exciting to work with companies of all types. So our goal is, as I said earlier, those are the problems we started to solve. Technically, we wanted to build a managed cluster management option. We wanted to give you APIs for container orchestration, and we wanted to build deep integration into the AWS platform. And what have we done over the last year to try and help you do that, especially in the latter two buckets? So when we launched ECS, we were available, if I remember correctly, in just one region. ECR was the same. Since then, both services have gone into 9 regions, and our plan is to be in every AWS region. Going forward, you'll find us being in every region on day one. That was true with our recent launch in Ohio. We believe these are foundational technologies that not just our customers, but other AWS services are going to build on. So we will treat them as such. Late last year, one of our engineers pushed a CloudWatch Logs plugin into Docker. This year, we took that initial plugin and then basically built an entire logging infrastructure. We get container logs and task logs and service logs, and you can push them into CloudWatch Logs. Once you do that, there's a lot of interesting things you can do. You can push you can send the data to S3 for persistence. You can put them into Redshift if you want to analyze your logs, or you can push them into something like Kinesis for streaming, or you can push them into Elasticsearch and build pretty Kibana dashboards. Basically, once you have logs, there's a lot of visibility you get into your application. I'll talk about that as well. We added auto-scaling at both the task and container level, and at the cluster level. Cluster level is just EC2 using metrics that make sense from an ECS point of view. But the real ask from our customers was to do auto-scaling for their ECS tasks. So you've heard me use containers and tasks a little bit interchangeably. So I just want to quickly take a sidebar. A task in ECS parlance is a collection of containers that you put in a lovely JSON file, and the system treats that as one unit. So all our APIs are actually, and functionality, are primarily at the task level. A task can contain just one container, but can contain up to 10 today as well. IAM roles was auto-scaling, IAM roles, and ALB were probably the top 3 feature requests we got when we launched AWS. So we delivered all 3 this year. Later in the talk, I'll talk about them in a little more detail. But essentially what ALB does, when you launched ECS, you only had one 1:1 relationship between your load balancer and the port on your host. And with ALB, with path-based routing and port management, you no longer have that restriction. And just about 10 days ago, I forget, very recently, we launched the ECS event stream. And what the event stream does is it takes all the state transitions that we capture in ECS and sends them to CloudWatch events so you can take action on them. It makes it much easier for you to build on top of ECS. It helps you do things in much more real time rather than polling our APIs all the time. So these are just some of the major features that we launched this year. There's a whole bunch of smaller ones. One not mentioned here is we actually updated our console just last week with a new dashboard. It'll even tell you things like if your agent's out of date. I think that's one of the things that bites a lot of customers because Docker moves fast, functionality moves quickly, and we keep revving our agent, and people often get left on an old agent version. And now they know when they are on an old agent version. So those 3 technical problems that we were trying to solve essentially came from this high-level question that customers were asking us and what we asked ourselves. People want to run containers in production at any scale. It's not just a toy. It's not just for hobby development. There's a number. You heard from Netflix this morning that they're moving significant parts of what they're doing over to containers. How can we support a customer like that? How can we support a customer like My Taxi that has their entire service depends on us being up and them running an application on New Year's Eve, the most important day for them? So you heard Werner talk about the well-architected framework this morning, and I'll try and cast sort of this in the context of the well-architected framework. So AWS launched 10 and a half years ago, something like that, 11 almost. And since then, we've had customers grow from small startups, grow from little tiny startups to Pinterest scale, for example. We've had Netflix come on board. We've had many enterprises come on board. And we've had the luxury of talking to a lot of these customers, helping them as they scale, helping them understand how to build applications in AWS, but also learning from them as well. Some of our customers are super innovative, and they've figured out great ways to scale their applications in AWS. And what our solutions architects did was take those lessons learned, both from helping customers scale and bring their applications on board, and from the customers who've become really good at using what we give them, and came up with the concept of a well-architected framework. And essentially, this is a set of questions that we ask customers to, customers ask themselves, and we sit down with them and ask, so what does it mean to run a well-architected application or a set of applications in AWS? And there's sort of 5 core buckets of a well-architected framework. Those are security, reliability, performance efficiency, cost optimization, and operational excellence. And I'll try and talk about the capabilities that we provide in that context. But essentially, the big part was we want you to be well-architected by design. There's a lot of things that people have to think about when they're building applications. And our goal is to try and meet as many of those requirements as we can right out of the box, or understand from you what it takes for us to get there. And it's an ongoing process, which is why we'd love to talk with you today and on our forums as well. And for us as service teams, it's not just true for us. All AWS service teams ask ourselves essentially this question. So let's go through this. The first and most important thing is security. It's like the level 0 of anything that we do. You need to have security at all layers. You need to be able to figure out what's going on. You need to automate your response. You heard Werner talk about response automation quite a bit this morning with the personal health dashboard. And you need to have principles like least privileged access. And at AWS, we give you a whole number of tools to do that. Obviously, we are responsible for all that stuff in orange or amber or whatever the color that is. And then we provide you tools to manage the top part of your stack, things like IAM to manage least privilege. The problem was when we started ECS, when people started using containers on AWS, they couldn't do that. There was no way to provide IAM roles and manage privilege, least access at the level of a container. So it very quickly became one of our most required features. But it's not just about that. We also need to do stuff like get various compliances so that enterprises can use us. We've got 2 right now. We've got ISO 27001, and ECS can be used for PCI applications, and we inherit some from EC2 because ECS runs on that, but we'll continue to make that a lot better. But back to IAM. What people wanted to do was they're running multiple tasks on a single host. Those tasks could come from different applications. Those tasks could come from different parts of the organization. Some of our customers give each team a different cluster. Other customers run one big, giant cluster that they want to logically separate out. And IAM roles helps you do that. You can run applications. You can restrict access to databases. You can restrict access to S3 buckets. There's a lot of control that you get once you have there. And as our identity and access management capabilities improve, you get the enhancements that they make automatically because they keep doing cool stuff too. So this is one of the first things that we focused on when at the start of the year, and we've had some great feedback from customers on what they're doing. And one customer that has done a great job of how they leveraged it, and they really pushed us hard to make sure we got this right, is Expedia. So what Expedia does is they're running production ECS clusters that serve about 200 applications. They have an internal CI/CD tool that leverages ECS. They have a custom ECS army. So the great news with ECS is you don't have to run our army. For those of you, I've seen tweets on this. At AWS, we don't call them AMIs, we call them armies, Amazon Machine Images. So they have their own with what their internal IT groups and InfoSec have approved. They do rolling instance updates as they reschedule tasks. They auto-scale using our auto-scaling features, and they heavily use task IAM roles to scope permissions to their applications. They're running 200 of them on their ECS resources from different teams with different levels of requirements and different levels of access. It allows them to run efficiently on top of the platform and get a really good security posture. And I think those are the kinds of things that when you start running container applications, you don't think about. But when you're an enterprise trying to move to containers and running applications in production, that's probably the first thing you do think about. And that's definitely one of the first things I get to hear from them when they're asking us which platform they should be using and how. The next one is operational excellence. It's a motto at Amazon, and we continuously ask ourselves how we can get better at this. But our customers have taught us some really nice lessons as well. You need to be able. I think one of the most important parts of operational excellence is how much automation you get through code and how much monitoring you do of your infrastructure. And those tenets are critical regardless of whether you're running in containers, whether you're running on VMs, or anything else that you do. So obviously, continuous integration and delivery is something I talked about. You saw that Expedia use their own CI/CD pipelines. There are others who use Jenkins. There's others who use other, there's so many tools out there. But ECS, especially with the registry involved, does a really good job of helping you build those pipelines. And you can use things like Lambda to add some custom hooks and do more custom actions to them. If you go to the ECS partner page, you'll get a list of all the partners that we work with in this space. Automation through code is something that we all take to heart. There's folks in this room who probably live and breathe that motto. We wanted to make sure that ECS are fundamentally automatable. So our task definitions, which are the core component, which is the first thing you interact with in ECS, are JSON files. We have deep integration with CloudFormation. You have customers and partners that take these CloudFormation templates or use Terraform to basically automate their entire infrastructure stack and then let the ECS schedulers do all the task scheduling, updates, etc. It makes it really powerful because you can automate provisioning, change management, and you get a lot of control over how your resources are being managed. That helps you run more safely. It helps you run with high availability. I talked a little bit about monitoring earlier today. It's not just through CloudWatch logs. There's a bunch of folks using things like, so ECS on day one had CloudTrail integration. So any API call that you make to ECS gets logged in CloudTrail and gives you audit. So it gives you not just access at the application layer, but you can also look at who's accessed the resources at what point of time, and so on. And there's a number of other features that we provide that help you do that. You can use Splunk. There's a really nice Splunk plugin for ECS. And last but not the least, I'm super excited about X-Ray that got announced today. So we are not natively integrated with X-Ray yet, but you can run X-Ray on top of ECS. And one of the things that X-Ray does is gives you information about how your data is flowing through the rest of the AWS system. And we're super excited over time about integrating with that and giving you even more visibility into how your systems are operating. Reliability has some of the same concepts as operational excellence. You have to be able to automate. You have to be able to recover quickly. Mean time to recovery is one of the more core tenets of building reliable infrastructure. You want to decouple your applications as much as possible, and that's the whole microservices side. And you want to be able to scale horizontally as much as possible. We talked about automation, so I won't spend too much time. It's generally true for any API-driven service. Things like CloudFormation or Terraform give you a lot of control over how you do this. Auto recovery was one of the key things that our customers wanted to do for long-running applications. They didn't want to have to figure out, OK, I got an alert, now I have to figure out how to restart my application. So the ECS service scheduler does a few things here. You tell it what your desired state is, and it works really hard to make sure that it can keep that desired state. Somewhat closely related to it is as you decouple your applications more and more, you can actually manage the state of your app. It gives you more resiliency because even if a single component of your application fails, it doesn't mean your entire application has failed because you've divided up into little components. And you can manage each of those as services running on an ECS cluster, and all of them have auto recovery built in. So it gives you a lot of advantages, and once you combine them with horizontal scaling, you can really scale your applications as your business grows, as your needs grow. As I hinted at earlier, ECS has two levels of scaling. your resources, your EC2 instances that are running underneath your cluster, get scaled based on cluster and service level metrics. So as your cluster is taking more traffic or as the services take more traffic, it'll automatically add more resources for them to consume. And then your services themselves, your tasks, can also auto-scale based on how much traffic they're taking. And until you need to launch more resources for them, they probably won't. So you get all the functionality auto-scaling at the container level, which is really empowering, has been a huge feature for our customers as well. The next one is how do you run your applications more efficiently and how do you reduce costs? You want to right-size your resources, you want to reduce your operational burden. And containers are actually pretty good at that. It's one of the big reasons that a lot of people start thinking about containers in the first place. You need to match supply and demand. You need to be able to figure out, you might take a big EC2 instance and run a few JVMs on it. With containers, now you can start mixing and matching applications and get better utilization of your resources, because now you're monitoring them at the CPU and memory level across an aggregation of resources. So it becomes super powerful. But we want to make it even better for you. Earlier today, you heard Werner talk a little bit about task placement. Very soon, we'll provide you with a task placement engine for ECS schedulers. What does task placement require, and how do we think about it? You have constraints at the cluster level. You have a certain set of CPU, memory, network ports that you need to satisfy. You have custom constraints. These could be location, which instance type are you running on, a particular type of machine image, some other arbitrary attribute that you want to constrain on. You have placement strategies. You may want to pack up a bunch of servers before you go on to the next one. Or for availability reasons, you may want them to spread out across instances or across availability zones. And at the end of it, you need to be able to apply all of these requirements through a filter and then select the set of resources that you want to actually go schedule on. So it's an optimization problem with many variables that you need to satisfy. So when we launch, you'll have a number of capabilities that you can, attributes as we call them, that you can filter on, things like Army ID, availability zones, instance types. You can explicitly go target something like a GPU instance. You can explicitly target an X1 if you're running containers on 2 terabyte instances. Some people might. You can explicitly say that you want your jobs to be spread out and only run one on an instance. Or you may want some custom attributes like a production stack that you may only want to. So you want an application, you never want that application to hit prod. Actually, better example would be just launch it in dev. And then at some point, you might decide to promote it to production. All of these capabilities will be natively provided with the ECS schedulers. They'll just be built in. You can make your choices and deploy them. Not only that, you have a bunch of placement strategies that you can bring along with them. Bin packing, spread, affinity, distinct instances, and you can do them hierarchically. You can say something like first bin pack and then spread, or some other combination of that. So really, really rich set of attribute-based placement features that we'll bring to ECS very soon. Really excited to do that. So more ability for you to run your infrastructure super operationally. Where does this really become important? Let's say you're a company that's growing really, really fast, that is running lots of applications, but has to be conscious of cost, and you can't have runaway costs as you grow. To talk about a little bit about how they leverage ECS to do that, I'd love to invite Will from Mattebox onto the stage to talk about how they capitalize their growth on ECS. Thank you.
Thanks, Deepak. Thank you. Thanks, everyone. It's great to be here, and I'm really excited about all the stuff that's been talked about so far at this re:Invent. I hope you're having a good conference. I'm on the platform team at Mattebox, and Mattebox is about adding location to any application. We offer customizable location services like maps that help you see the world in stunning detail, geocoding or search that help you find places and addresses, and directions that help you get from point A to point B. All these services are delivered as developer-friendly tools and SDKs that can really just drop into any application and add location there. Customers of Mattebox include the Weather Channel. They use us on their iOS and Android app to render animated radar and satellite weather maps. And they use our geocoder, our search, to help people find the weather for specific locations quickly. Or Airbnb, they're using us on the web, using custom markers to show the locations of properties that are available to rent. Or someone like CNN, they're helping people understand where news is happening using a custom satellite-based map and a custom street map that's optimized for data visualization. And finally, National Geographic, they have a gorgeous city guides app that that guides people on walking tours of the world's most iconic cities. We're powering over 55,000 apps in categories ranging from social to mobility. And we reach over 250 million people, unique users, every month, and that number is growing. So in order to power these use cases and provide maps to our customers, we need to build a map, and that requires a lot of data. So if you take a traffic map like the one that's on the screen that we're probably all familiar with, you can zoom in here and see the level of detail that we have here. Where does this data come from? Well, the way it starts is it looks like this. It's a bunch of dots. We're collecting billions of probe points from our SDKs and other sensors, and it comes into our pipeline. It's like this. And we process that on EC2 using ECS and turn it into something that looks like this. So what we're doing here is anonymizing, aggregating, and snapping points to the road network. And then we look at the speed of those probes and calculate the prevailing speed for a particular road segment. This is how we build the traffic map. Not only the visual map, but also routing you around congestion so that you can get to work on time. This data covers entire cities. This is Washington, D.C., and continents. In fact, we're collecting over 3 billion probe points every single day, and that's equivalent to about 100 million miles worth of data every day that's coming into our system. So I want to talk about how all of this runs on AWS, and as of recently, it's all running on ECS. We just finished a massive migration of all of our microservice infrastructure to ECS. And right around the time we started that microservice migration, we're seeing growth in 3 key areas of our business. The first one is on our team. So we have more people joining our team. We're onboarding more people to the applications, how they work, the infrastructure, how that works, and we need to figure out a way to scale that. The second one's functionality. We're writing features faster than ever and shipping those out to customers. And finally, the third one is traffic. We were onboarding the biggest customers we've ever seen, and we needed to scale our infrastructure to a whole new level. So I want to talk about how we used ECS to address these problems, to overcome those challenges, and not only overcome it or survive that growth, but massively capitalize on it. So the first one's in team. So ECS really provides a super elegant separation of concern. On the one hand, you have your application with features and functionality that your customers want. And on the other hand, you have your infrastructure, which has your lower level configuration, your EC2 configuration, your network configuration. This is what our infrastructure used to look like. It was monolithic. We had microservices, but each microservice had an infrastructure attached to it in a monolithic structure. ECS allows us to decouple that so that the infrastructure and the applications can move independently, influence each other, but they evolve independently. And that's really, really important for scaling our team, because you can deploy changes to an application without having to know how the entire infrastructure works. And then the other way is true as well. You can make lower level infrastructure changes without having to understand every single detail about an application. So that's massively helpful for scaling up our team as we grow. The second way that ECS has really helped us is in the growth of our functionality, adding more features. And one of the biggest things, in addition to that separation of concerns that helps, one of the biggest things is deploying. We need to be deploying faster. We need to be deploying more every day. And our old way of deploying worked well. What we did is we had a particular version of our application running, and then we'd spin up entirely new EC2s, wait for those to become healthy, and then shut down the old EC2s. And this worked really well for a long time. This works well with 10, 20, maybe even 50 instances. But when you're talking about hundreds or even thousands of EC2 instances, you get into a territory where one EC2 boot failure can disrupt your entire deploy. And that sends you rolling back. It really impacts your ability to move quickly and deploy multiple times a day in order to get the features out. So not only when deploys failed, that's not the only problem. Deploys were just slow. Sometimes deploys would take, a simple deploy would take hours to deploy across our 10 AWS regions that we're running in. So we really needed to solve this problem. We needed to get our deploys from hours down to minutes, and we were able to accomplish that with EC2. ECS, and that's been massively helpful getting that functionality out to customers. The other nice thing about fast deploys is it means rollbacks are fast too, which is really critical. If you deploy something that's not quite right, it's very, very quick to undo that, and that's really helpful for maintaining our SLAs with our customers. So the third area that ECS has really helped us grow is in terms of our traffic. And that's not just scaling up more containers, running more tasks, running more containers, which is definitely true. We're running more containers than we ever have been before. But cost is also a big factor in that, because that's what we all worry about. As we grow, how do we achieve better margins, lower COGS? How do we achieve economies of scale? And the first way that ECS really helps with this is instance packing. So we have applications that are very CPU intensive. They use almost all of the CPU of an instance, but almost no memory. And then we have other applications that use a lot of memory and almost no CPU. What ECS allows us to do is run both of those applications very, very easily, almost automatically run those on the same instance. And that means we're able to run fewer instances, which simplifies our infrastructure. It also saves money. So we're more fully utilizing the resources we're already paying for. The second way ECS helps us save money is making it easier to use Spot. So Spot allows you to bid on unused EC2 capacity and get at a fraction of the price. You get a huge discount. But the key to using Spot is to diversify at scale, to diversify across various types of instances. You can't run on one type of instance, because what will happen is if you lose that type of instance, you need to be able to move your application over to another instance type. So with Spot Fleet and ECS together, Spot Fleet will replace those lost instances with a new type of instance, and ECS will move our containers over to the new capacity seamlessly. We are not tightly coupled to a particular instance type or family. We can really run our application very easily and automatically on various types of instances. So these two cost-saving measures have helped us run 25% fewer instances by packing the resources better. And it's resulted, that plus Spot has resulted in an 80 to 90% savings on our EC2 bill. Pretty massive impact on our margins. So ECS has helped us in terms of growth of our team, growth of our functionality, and growth of our traffic. We're running 21 services, 2,000 tasks, and it's powering an API that serves 1.3 billion requests every day. And it's doing it all with incredible margins that we never thought we'd be able to hit before. So all this comes together to mean that Mattebox is ready for the next phase of growth. Thanks very much. Thanks.
Thank you. I like billion. Like anytime you see billions on the screen, it makes me happy that our service can do so well, helping Mattebox not just scale, but also get them more efficient. And hopefully, with the new task placement features, you'll get even more efficient, because those are the kinds of problems we really, really want to get good at. I think it's something that we strive to do, and and it's exciting to see how customers are using our services. I'll add a sidebar. The combination of Spot Fleet and ECS is actually a very, very awesome combination. For those of you who have not used Spot Fleet, you can select fleets of Spot instances and give it some high-level requirements, and the Spot Fleet engine will do the bidding for you within the constraints that you give it. And especially if your applications are not coupled to a particular instance type, and you're running it inside ECS clusters, which are fundamentally heterogeneous, you can get some really, really interesting properties. And it was something that we thought about when we launched. We didn't expect lots of people to do it, but looks like people are, which is awesome. Moving forward, and we think of ECS as a foundational technology at AWS. What does that mean? We obviously had a lot of customers who were asking us to provide a managed container service that they could use to build their applications. We also had a lot of teams inside Amazon and AWS that wanted to do that. So we not only have to think about what are the needs of every customer that we have, but also internal teams as they scale, as they build new applications, as they build new services, what could we do? That's a big, big reason for us building our own container management system in the first place. An example, and so it's not just about EC2 and S3 and Dynamo, so three of the core foundational services at Amazon. We think of ECS and ECR very much in the same vein, not just from a functionality perspective, but also from an operational profile. How many of you have bought stuff on Amazon? Just curious. OK. Just checking. You may or may not have used the recommendation engine that tells you things like if so-and-so you bought so-and-so, other people bought something else. That's our personalization engine, and it's been at Amazon for a long, long time. But that team has also, over the years, enhanced how they do it. They use a lot of machine learning software. They now use GPUs to train neural nets to do it. But they were scaling that. They have to scale their personalization system as well. And they wanted to figure out how to manage these clusters. And they were running into all kinds of problems. And they decided to leverage ECS. I won't go through the whole architecture of their personalization engine. But to summarize it, they use ECS as sort of the master of all resources, and they use custom placement systems to make sure that they're targeting their applications to P2 instances, which they use for their machine learning models, and they combine it with Spark, of all things, to get some really, really interesting capabilities. And that's one of the it's something I'll talk about a little more in a bit. But people building custom sort of orchestration on top of ECS is not uncommon. Because we have a decoupled system where orchestration sits on top of the core APIs, you can do some very creative things with ECS. And a great example of someone who does that is the Amazon personalization team. About 8 years ago, when I joined Amazon, actually even before that, 9, my first use of Amazon was to do batch computing. It was, my wife and I wanted to process some genomes, don't ask why. But I had some old code sitting around from grad school. She had the data, and we didn't have any compute. We had one computer at home to try and process this on. And this is 9 years ago. And EC2 was still pretty new. I had played around with it, but it was pretty cool. We spun up I think about 20 instances. That was my limit. Processed all the data, and we had the models that we needed to do our little hobby project. It was kind of cool. 6 months later, I ended up joining Amazon because that was so cool. So batch computing is something I'm super passionate about, and so are our customers. They've been using EC2 for batch computing from the very first days. Our first customers that I worked with were hedge funds doing backtesting and things like that on EC2 at night. And people have built 2 kinds of applications and had to do this in 2 ways. They either bring in some scheduler that is built for a fixed size cluster system, or they end up writing a lot of their own batch computing orchestration. And you heard a little bit about it this morning. And many of them have started using ECS, so we wanted to change that. So AWS Batch, which you heard about today, is built on ECS. It takes advantage of ECS's resource management system. It takes advantage of ECS's placement system. And then they build in the orchestration system that manages queues, that manages priorities, that makes decisions. With AWS Batch, you actually don't have to pick instance types. It'll pick them for you. It'll actually scale your system when you're, depending on how busy it is, and you don't actually have to think about it. All of this became a lot easier for us to build once we had ECR and ECS. You don't have to pick Docker. You can run shell scripts. You can put executables. It'll actually essentially do a deployment for you behind the scenes and on thousands and thousands of instances if required. So that was a very cool enabling technology for us as we were thinking about how we build a batch computing offering. And we'll keep enhancing this as we go along and as ECS builds more features. So those are just 2 examples of how we think about AWS. You heard from Mattebox about how we enable customers You saw a little bit about Expedia. And these are two internal, one Amazon service and one AWS service that are built on top of what we do. So we really, really care about making sure that we can help you scale. I'll skip those because I kind of talked about that already. And there's a more detailed batch computing talk later. In the interest of time, I'll keep going on. So, awesome. I talked about people building custom schedulers on ECS. And part of that comes from, and in fact, AWS Batch is kind of like that as well, is people want more control. Our developers keep saying, hey, we'd love to have more knobs to move, more kinds of applications we can run. We try and build well-architected systems, and our backend will make sure it's that, but people want more features. They want more capabilities. So how do we give them more control and the ability to customize what they need? So here's what they wanted to do. They wanted to do Windows containers. So it's actually something that we haven't made a big noise about, but as of last week, you can run Windows on ECS. And I think next week, yes, Scott, you'll be able to put Windows images inside a registry. Actually, you can actually switch between OCI images and Docker images through using the registry as well. I talked a little bit about our console improvements. I talked about the task placement engine and attribute-based scheduling. And the event stream. And the last sort of 3 features together really, really form a powerful system that our customers can then leverage to do more with ECS. So we started thinking about how to make this available to customers. What's the right form for us to do this, and how can we make it possible so that they don't always have to wait for us to integrate it into the full platform and operationalize it, et cetera. That brings us to AWS Blocks, brings us to Blocks. Blocks is an open source framework for container orchestration and scheduling on top of ECS. What does it do? It helps you create custom schedulers. It can integrate with third-party schedulers, something you may already have. And our goal is to make it easier for you to develop locally, test, and then deploy into production on AWS. That's kind of what our customers ask for, and that's what we are trying to solve with Blocks. And today is just the first release. What you'll get today is, that's not the direction I want to go. Yeah, that's where I want to go. Today, you get 2 components, a cluster state service and a scheduler. We'll also, over time, our plan is to move the ECS CLI into the Blocks project as well. Let's talk a little bit about the cluster state service. And I won't spend too much time on this because at 12:30, you'll have a whole detailed demo and description of not just Blocks, but also the task placement engine. You'll actually see them in action very soon. So that'll give you a chance to see how it works. But essentially, the way Blocks works is you have an ECS cluster. You now have an event stream. What we found our customers were doing was they needed a way to, as they built schedulers, earlier they were polling APIs. The event stream takes that problem away. But after that, they had to figure out a way to persist those events, that state of the system, across maybe multiple clusters. They needed a way to search and filter, and they needed an API on which they could write schedulers. And they were building all of that themselves. So the cluster state service is essentially a piece of code that does that. It also periodically syncs with the ECS cluster and actually reconciles state if there's any drift between the state of your on your local. The cluster state service can run on your laptop, and it makes sure that the state has not drifted. And on top of that, you can then build your own scheduler, and you can periodically query this state service for building your schedulers. You can run the state service on your laptop, on an EC2 instance, on ECS. Our goal is to have you run it wherever you want. And along with that, we are also providing a daemon scheduler that essentially serves as a reference for how you build schedulers on AWS, on ECS, but also gives you a functional scheduler that many of our customers have wanted, where they say want to run a logging driver or some other kind of process, but only one of those per host, and restart them if something happens or new hosts come into your cluster. So what's our vision? And I'm super excited about this. The team's been working on this for the last few months. We're just getting started, is to give all of you more control and actually to work with you to figure out where to take our service in the future. So what we are releasing today, helps you get started. Our goal is to give you a selection of a wide variety of schedulers, either schedulers we build or schedulers built by the community. We wanted to give you a consistent development experience that starts locally and ends up on ECS. So you'll get a lot of common abstractions, a common ability to model these applications. But really, I'm looking forward to what people do. We have customers who want to run something like Marathon on top of ECS or Kronos. This is a mechanism for them to do so. We've already had pull requests on other kinds of schedulers coming and running on top of ECS since the announcement was made this morning. So super exciting times. But it only works if all of you get involved, and we'd love to work with you. So, that's the URL. Join us in our GitHub channel, submit pull requests, submit issues, and you'll find that the team will work with you, will be super excited to work with you on blocks, understand your problems, and we would love to see where the community guides us over time. So I'm running out of time, so I'll try to wrap this up. I know there's other talks in other parts of the building. So what does this mean? So you heard from, actually, I forgot this slide. You heard from Neil Hunt earlier today about how Netflix is adopting blocks. There were actually key drivers for us starting to use Block, to build blocks. Where they're running 100,000 instances. They have lots of microservices across their entire infrastructure. But they started adopting containers to improve for some of the same reasons that Mattebox talked about, for developer productivity reasons, so to make their teams faster. But they also wanted to do a lot of customization. And they have a system called Titus. And they're moving that system onto ECS. And Blocks came out of our collaboration on trying to understand what those requirements for them were, what would make it easier for them to do so. And we're super excited to keep working with them on taking it forward. So we have a full agenda today from some of the customers you saw earlier, from our engineering teams. You'll see a comparison between all the various container management platforms that we have, and sort of questions that you can ask yourself to make those decisions. You have talks on microservices. You have talks on image optimization. You get a deep dive on blocks and on the EC2 container registry. You'll hear from folks from Netflix, Capital One, Rent-A-Center, Pinterest, Instacart, weve, and here, and probably more that I'm forgetting, so apologies. Thank you for coming.